Well, hello and welcome to Live Stairways. This is class 4 of the Stairway to DAX and Power BI. I'm Steve Jones, and we are going through this Stairway series live. So every Thursday, you can check out and go through these live. Or if you're going through this later and watching the recording on Redgate University, go through them each time. There's a forum available on the Redgate Hub, which I should pop up, I guess, where you can actually ask questions if you've had any or you have any in the future. Here in the community circle, we have the classes, and I think these are going to move to the Redgate University at some point in time. But the DAX and Power BI class is listed here with the overview, and then there is a course discussions link that actually has a place where you can post it. So I've posted a few items in here, but I will be notified if you post other things here in the future. So please feel free to do that. So far, we have been through the first 5 levels. So today we're going to start looking at level 6. The homework that I had posted before was to actually go through these articles and read them so that we don't have to read them together and you can get some understanding. I've done that, and it led me to do a couple of things which I'll explain as we go through this. So the opening explains that we have sum and SumX. So sum is an aggregation or measure function, and SumX is an iterator. Now, I've seen this in the past when trying to understand DAX examples. I never quite understood what it was. In this case, I'm not sure this is a great explanation, but what I learned from a Pluralsight course, actually from Eugene Meidinger, was that the SumX, or the X functions that are iterators, are actually going row by row, whereas the sum functions are taking the whole data set at once. So that helped me to get an idea of what's happening here. Doesn't mean that you shouldn't use the iterators, right? In SQL, we tend to try to work with group functions, not iterators or row, by agonizing row type functions. It just means you're aware of what they can do. And so in reading through this, Bill does do some explanation about the differences, but he uses different examples. So one of the things I wanted to do today in working through this is try to repeat the examples in each one so we could see the differences and effects. I haven't tried these things, actually. I just read through it, but that was something that occurred to me. Now, this preparation section is repeated for much of these articles, and it involves getting the tables and information down. The one thing I did notice here is that he's actually changing the friendly name. He's renaming these tables, which I wanted to try to do today in DAX. So if I were to come into my data model, and I were to pick one of these, I do have a rename here. So I could change this to account so that it's a little bit easier to read. Now that should flow through to any place else that I've done something without an issue. And in fact, let's see if that's the case. Let's see if that actually happens. So if I go to here where we have this visual is actually using the fact reseller sales. So let's change that. Let's go back to our model. And what does Bill do? He just changes it to reseller sales. So fact reseller sales is over here. And if I say rename and I rename it, I assume my visual will still work, but let's actually check. So coming over here, the visual, I think it's still working. If I pick this one, what does this now say? Sum of reseller sales, sales amount. So it has updated things here. This now says reseller sales. So I don't necessarily want to rename all of these items because that could be a lot, but I will rename a couple of them because I know they're used here. And maybe if I do a couple each class or periodically, that will be helpful. I do find that people that do some of this analysis work, as I talk to them about the actual things they do, or I see some of the items that they complain about, some of these types of items where people are actually going through busy work of doing something like renaming tables is something they wish was easy to do in things like import, like get rid of the dim as a prefix. But In any case, let's keep going. Let's see where we are. So there are no new tables that I see here. I think all of these are listed. One of the things I did think, though, was as I go through some of these tables, these examples from Bill, and we look at these numbers, let me just scroll down. I'm jumping around slightly, but I just want to show you why I did something. He's writing some formulas here to do some different things. And I feel like I've got some, they're there. As you say, here's a sum, a calculated column of some sort with a very complex number. Now, at some point here, Bill actually has you, or has us, paste in some numbers into Excel, as we can see here in this image, and then total up the value to see if that matches. To me, this makes perfect sense. It's the kind of thing you probably want to do when you're building reports to make sure that your filtering or your expressions are correct with what you're trying to do. But these are cumbersome to work with. And honestly, this is where I like to have tests in my T-SQL because I want to verify simpler formulas are working correctly in the way I expect, rather than working with, I hate to say real data, but complex data like this. So in looking at this example and trying to figure out how could I double check the way that sum and SumX work in different areas, I thought I should actually come back to a simpler set of data, which I think would make things easier. Where's sum? So sum is right here. We'll start here. So this is what I did. In my AdventureWorks DW database, I actually created this table with just 5 rows of data. And you'll notice that my sale amount is just increasing by 10. My sales tax is increasing by 1, starting from 1, and my freight is increasing. And I've manually totaled these up. So in this table, I can kind of easily grasp this in my head. One of the problems I think as a human working with large amounts of data is holding complex calculations across non-trivial numbers and volumes of data is difficult, but having small amounts of data often helps me to understand things. So I'm going to add this to my model, because what I actually want to do is use this to test some of the things that Bill is doing. We will go through his sums with those. I should do it this way. With the examples that he has with the tables from AdventureWorks, but I wanted to try to do this with some simpler ones as well, so that we had the chance to see if there's a difference, or if it makes more sense, the difference between sum and SumX. We're also going to try to do average and average X today as well, and there's an off chance we'll get further, but we'll see. So I've connected to my database. I got the encryption warning. I'm going to do this sales sample table, which just has those 5 rows of data. So I'm just going to pull that in as an extra table, and we'll run some experiments with that as well. In some sense, it duplicates a similar set of data to what the examples in the article have. So while that loads, let's pop back over here to the article, and let's start in the sum function. So sum, most of us have used sum in T-SQL. We've used sum in Excel. It's an aggregation function, so it tends to work on aggregating everything in a column. So in this case, Bill is noting that I could have a sum value where I've picked a particular field, and if I drag it into the pivot table, I can see it's summarized by sum. So it adds the numbers in a column, essentially, right? And that's what the argument is to the function itself. So the output is numerical value. It's used to design and create subtotals and totals, and employed with other DAX functions. Should be an S right there. In any case, SumX allows us to extend the logic of what we filter. So it's slightly confusing here because it says sum is used to create subtotals, but yet it's doing everything in the column. Now, we use sum to return a subtotal total, so it must be a capability, though I don't see an example of this. We use sum in a calculated column to get something, to get a column here. So let's try that, actually. Let's create a new calculated column, and see what it says. Now in Power BI, he's doing this in reseller sales. So if we come into the model and we were to pick reseller sales, I don't know if I can actually insert a column here, but we can try. So let's try. If I were to right click here, there is a new column. There isn't an insert column, but let's try a new column and see what happens. I suspect it will be at the end, but we'll see. And it is at the end. So we can say sum of sales amount, reseller sales amount, which I believe is what Bill, oh, he has product cost. I was misreading that completely. Standard cost. So let's put that in there. Oh, it's not a very good name, of course, but let's see what we get. And we get this 26,693,000, which is what Bill has here. Let's go ahead and rename that to be some. Helps if you can type better. And that'll be our new column that we've actually added here. All right. So it deserves the, let's see, calculator returns the desired outcome. Makes sense, right? It's everything. Now, why would I want every value in this? Why would I want the total for the entire table in this one column? Sometimes you're trying to access things and you're filtering on certain things, you're accessing certain data in a report, but I need the total somewhere else. So that's always available to me, even if we've filtered out items. So this does make sense to me. The DAX engine and the storage engine should be compressing this quite a bit, so this doesn't really take a lot of space. So I tend not to worry about these things. Now, so sum X is different. It returns a sum of an expression that's evaluated for each row. So we're still calculating a sum, but we're not calculating on table level, we're calculating on the row level. So it's an iterator function that's working row by row, essentially. This is the same for other functions, sum, average, count, max, min, etc. There are X functions available, which we'll see if we get to average here. So what we want to do is we want to filter a table or column based on criteria we specify in the second expression. And then what comes back, what's the result of that filter, is what gets summed together. So performs calculation for each row, blank text and logical values are ignored. That's good to know, because in SQL, if a row has, well, it's a numeric value, right? We couldn't have blanks or text, which is interesting to know. So the syntax is table and expression, which is interesting because I would expect column in there as well. And actually, I want to double check that. So let me pop over here to DAX, X. And we'll go to the docs in Microsoft. And that's what it says, table and expression. So that's it. So it says this is intuitive once we grasp the purpose. I hope so. I'm still not 100% positive on these. So what are we going to do? We'll get a feel for this. Sum X of the table reseller sales, and the expression is tax amount, which is in fact a column. So it calculates the tax amount for the respective sale for each row and then returns a sum of these tax amount values. So in this case, there's no filtering taking place. We're taking the entire column, the entire table here. So let's get some practice with this. As a matter of fact, let's just see. Let's add this and see what happens. We'll say new column. And once this appears, I'm going to call this sum of tax amount. Sum X reseller sales X amount. And close out the parens. And do we get 6,000 something dollars? I hate that this model resets. That's kind of one of those poor UI experiences. We do. We get this, or 6,436,000, which is what Bill gets as well. All right. So the hands-on practice is where we walk through this. Again, the articles use Power Pivot in Excel. I'm using Power BI because Power BI kind of includes Power Pivot, and really, I think, has superseded how most people would do reporting now. Instead of Excel, they would use Power BI. Certainly, if you want to use Power BI, you can do that. So let's say he's saying insert this column, calculated column, and then he's going step by step. So he's pointing through, finding the functions, going through there. And by the way, I do think that is there a way to get a list of functions available? So I don't see a, oh, I say I don't see. Certainly once I do this, I get a number of items. So I do get all these functions, but I don't have them broken out. So if I said trig, I don't see a way to go through those. So I think one of the upsides of Excel is it sorts functions and I can insert something in there. And I don't see that in Power BI. But if somebody knows something, please drop a question or a note in the discussion and say so. So in this case, he's going to say sum of sales amount. I think that's where I was confused. And just close that out. So once he does that, he'll see the sum of everything. So I'm just going to go ahead and change this. Sum of sales amount. Sum reseller sales amount, which is what we have gotten, or internet sales. Oops, sorry, my bad. Internet sales amount, close the parentheses. And Bill is getting this $29 million number. And let's see if we get that as well. So 3, 1, 2, 3. So it looks like it's a $29 million number. It isn't a number though. Whole number, we want a currency, I think. And that should clean that up and give us numbers that look like these numbers. Okay. So we call that total internet sales. We could do this as well and call this sales. Now you'll notice I added that to the reseller sales table, which I'm working on, because I can just reference anything in the model. I can do that. In this case, I think Bill is on the internet sales table or sheet in Excel, but yeah, he's on internet sales, so you can do that. But I can do that in a different table. Now I'm going to duplicate that with the small table I made as well, because I want to see how this might appear differently when we get to the SumX spot, which is here. So there's that 29 million. So that's here. That's where we were, is at 25. So we'll do something with SumX. So let me actually come over here though and pick our sample table, which is very small. And we'll say new column. And we have a sale total. Let's call it sum sales, sum. And let's do sample. And let's do sale total. So theoretically, what I think should happen right now is that we're doing a sum. So we're getting the entire column here. We're summing up all 5 of these numbers, and that total will appear for every row here. So that's 110, 40, 60, 70, 80, so 195-ish. That makes sense. So to me, that's easier for me to look at and go, this is roughly the sum of these 5 numbers is 195. And let's change that to currency. Let's change this to currency, which I think might, I don't need to do that. It's, I don't know. It makes me happier to say numbers and numbers and financial figures are financial figures. All right, so let's look at sum X. So in this case, so Bill is looking to insert another column here. So he's doing another insert column. We'll do add one at the end. In this case, he's doing sum X. And now he needs to do a table and an expression. All right. So he wants to do this in internet sales. I'm actually going to go to the internet sales table and do this there. So we'll say new column. And I know he's doing this power pivot, so maybe it doesn't make sense, but it is slightly maddening that the name is not first. So he's doing sum X of internet sales, comma, equals sum X of internet sales, comma. So now we're in the expression area. In the expression, he wants to do a bracket, get the sales amount, and then add that to the tax amount and add that to the freight. So he's actually looking for this formula here. I know I've got an extra comma there, but that's okay. So we'll take that comma out. And then he's going to rename it to total build amount. So let's just put that in there. I know I've got quotes there, but that's okay. Total build amount. And so he's got $32 million here for this value, which is what we see here, 32,441,000. That matches up. Now, if I were to repeat that in my small table, which is in fact here, notice I have tax freight here as well because I wanted to capture those values. And so what he's actually doing is he's got the sales amount, tax, and freight. So I've got sales amount, tax, and freight. So let's add that as well to the same column, and so we can see if there's a difference in what actually appears here. So we'll call this sum X sales. It's called total sales equal to sum X, and we'll give it the sales sample, and we'll do here sale amount plus sale tax plus sale freight. Close that down. And so that's roughly the same expression that we did for the larger table and the smaller table. And what should we get then? We should get the same numbers because theoretically this sale total is the sum of these 3 numbers. So this is 13, this is 26, 39, 52, 50, 65, 65. So summing up these and then summing up all of these should be the same, and that's what we see here. And I did it this way specifically so that I could just double check how these formulas work. Now, we have that column. He's got build amount there. So sum X could be a total of totals. So now he wants to change that second argument to be a little more sophisticated. So one of the problems is sometimes if we drop this onto a report, this will get summed up because it'll be 195 for every row because there's 5 rows, which is a sum of sums. That's not really what we want in some cases. So that can be problematic when it's that column and not a measure. So now he's going to do something different where we're going to do a sum X, but we're going to do a filter expression on there. Now, filter allows you to pass in a table, and then what you can do is apply criteria to limit the number of rows that are actually returned. So we're adding a new one that is a filter based on the order key equaling some value. So let's take this, let's create a new item. Now he's jumped to reseller sales here, which is where I think I got slightly confused before when I was reading this. Reseller sales, we have a new column that's going to come at the end. And then we're going to paste that in. And then we're going to say the order date key is equal to this value. And now this closes the filter, not the SUMX. All right, so remember SUMX is a table and then an expression. So in this case, the table is a filtered table. They're taking reseller sales and we're filtering it down into one particular order date key. And just those rows are being returned to the SUMX expression. And then discount amount is what we're putting in there so that that's the end. So discount amount, and that closes out my SUMX. So when I run this, or sorry, not I run it, but I put this as a new column, maybe I need a quote here. Nope. Let's try this. Let's say order date key is equal to, maybe it's double quotes. Is that look correct? Oh, that's an interesting one. That filter is working differently. So let's come over here and let's say function. Let's see what it comes out. So what would be wrong there? Syntax for equals is incorrect. Maybe it's double equals? No, in some programming languages. Yeah. Let's try it this way. Using filter in there's I'm partial to simple talk rather. So he is in Power BI. So he will go SUMX sales of something, SUMX sales price quantity. So you calculate USA. So we're in reseller sales already. So it looks like I'm correct, I think, but filter sales something equals something. There. And this would be my filter, and then this would be my SUMX. So what is wrong with this expression? So it's a syntactical error, clearly I'm making a mistake with. But what is my syntactical error? Let's try. Equals New York. So debugging using the filter. Well, that's not a date field though. Where's order key? What is order date key? That is a whole number. So it shouldn't be, in fact, a date, or it shouldn't be a string. It's a whole number. So it shouldn't need this. Reseller sales, order date key. That's interesting. Let's get rid of this. If I said here equals 1, is that correct? Nope, it's still incorrect. Maybe, oh, maybe it's this. Is this incorrect? Let's try typing it from reseller sales, filter. And we'll say the table is seller sales, date, key, 825. I don't remember the value we were looking for here. 2050801. I was actually correct. No, I wasn't. 2050801. 801. And then we'll close that. And then we'll say we want to return discount amount. And we'll close out that expression. What are the odds that works? No, it's still an equals error. Boy, so I am highly confused about where my error is. Unexpected parameter. Oh, I don't need reseller sales. I've got too many things there. Sum X filter. Why did this not become capitalized? I don't know if this error is real time or if I have to do something else. Boy, that's interesting to me that I can't do that. So if the syntax for equals is incorrect. Let's take filter out for a second. And I said, I did this. I get a value, I think, right? Nope. How about that? Table expression. What did I do differently in the expression up here? Gave it a table and then just a series of columns. Oh, boy, I hope that wasn't it. I had two equals there because that would be maddening. If that's it, then let's add the filter back. Okay, so that worked. So let's go filter. In this case, reseller sales. Let's close the filter and we'll say comma order date key equals to 05 of 801 in the end. And wow, so two equals expressions made me insane right there. So I assume that there's values somewhere down here. If we come down, I need to find the order date key. So 2000. I don't know how these are ordered. Let's get that way down. Where's our order date key? So 2013. Maybe I don't, in fact, have 2005. Let's do 1129. Let's change that and see if that changes the value. Bill did this with the 2008 AdventureWorks, and I have the 2014. So what did I do? 13, 11, 29. Was that it? Let's put some there because there should be something for every row here, right? Because we're getting a singular value across those rows, and I get something there. So let's copy this into our small table and see if we can do something. So sales sample, we'll add a new column, and I don't think we're going to get to, maybe we'll get to average briefly, but sales sample, new table, which is not at all what we wanted to do. I wish this was separated out, so let's cancel this. See if it goes back to sales sample. Tell you what, if I work at Power BI, I'm going to want to get paid by the hour. New column, just because I've got a very powerful machine here, and it is dragging a bit. All right, so let's get rid of this. Let's only have one equal sign at this time. So I'm just going to say sale freight for 3. And so what I'm going to do is I'm going to come here and I'm going to go sales sample. And now what I'm going to do is I'm going to say sale key is equal to 3. And what I want to do is return the freight. So if I filter this out, my reading of this is sales sample table. We're going to take sale key equal 3, which is just this row. We're going to return sale freight, which is 6, and we're going to sum that up. Make sense? If I say yes, I should see 6 all the way down here. Now, let's change this slightly and see what's going on. What if I change this value to say less than 3? In this case, less than 3 would be, let's do less than 4 so my number actually changes. 1, 2, and 3 here. Sale key less than 3, yeah. So I'll add up 2, 4, and 6, not just 2 and 4, which would give me 6 again. So I should get 12. Ta-da, that works. Okay. I'm getting somewhere, I think. All right. Filter reseller sales, we did this one. The next part of this is actually finding that data, which we didn't have, right? We have different data. We were 2013, 11, November 29, and pasting that into Excel somewhere else. So he's got just those rows of data. And then he's using a sum in Excel to see if it's the actual value. I think we proved that by going to the sales sample table and actually getting that done. Now, what's the difference here, what if I were to get the sum, just the total sum? Well, in the sum, I don't have a way to filter out values, right? Because sum is just takes a column. I suppose, and filter doesn't allow me to just return a column here, right? Because this is the filter expression. Here, it returns table. Doesn't quite work, but now he goes to a measure. So let's look at a measure because I think we're getting close to where we'll stop here. Next time, I think it'll work a little quicker to go through the average one. So we'll look at the future here in a moment. So he wants to create a measure. So he's actually going to create a pivot table and start to add things to it. We'll do this with a visualization as well, but first let's create the measure. So in Power Pivot, you create the measure from here. We'll actually want to create the measure from somewhere else. So I'm just checking to see where he creates this measure. So he says new measure here. And he's going to say, give it this name. So he uses CM as a naming convention so that you know it's calculated measure. So I'll do the same thing. So total build amount CM. So internet sales, and we'll do total build amount. So internet sales, we're going to add a measure. So let's close these down slightly so we can see what we're doing. Internet sales, we're going to create a new measure, which will create that formula. Okay. Total build amount CM. So that's good to know. I think that's actually a good standards-based way of doing this. So when I've talked with Bill in the past, and I think I just lost my new measure there. Measure. He works with a lot of clients that have some very, very complex accounting systems. You know, Bill, I think Bill is an accountant by training, but you know, he does a lot of work with accounting firms and customers, and trying to deal with all of these columns and measures and aggregations that are available. I think it makes sense sometimes to have something like CM that clues you in that this is in fact a measure. So in terms of the measure, what he's going to do is he's going to use sum X for the measure for internet sales. So let's do that. So sum X internet sales. We're following along. Now we need an expression. And his expression is going to be sales amount plus tax amount plus freight. So the same sort of expression that we had before. But this is a measure, not a column. So once he does this, it's available as a measure, or we do it actually. And let's go look for a second in what's happening. So I'm going to create a new page, and I'm going to rename this to SumX, and we'll create a table. And then what Bill actually has dropped into his table is the English product category name, English product subcategory name. So English product category name, which I think you got from products, is that right? Product category and product subcategory. So product category, so we've got the English product category name, and then the English product subcategory name. Yeah, and so you see that these are related as a parent-child. So we see accessories here, and it splits down just like we see here. Now in the pivot table, there's some collapsing going on, whereas we have it all there, but that's fine. And then what he wants to drop is the total internet sales and total build amount. So those are from our internet sales. So total build amount and total sales. So I don't think we added as an item. Now you do notice that down here, this is a column and this is a measure. This is my calculated measure. And they're shown as icons as different numbers here. So total build amount and total internet sales. So when we look at this, that's summed there. So this is $1 billion, which is clearly not correct. But what has happened is I think this is being added up for every row in these categories that it finds out. So it's got the sum and then it's being added over and over and over again. So it's actually adding that in there. Now this is different when we drop the measure in there, because in the measure, when we drop this in there, we get a more reasonable value. So let's drop that on there too. And so selling bike racks at $43,000 as a measure makes more sense, whereas $10 billion doesn't quite make sense. As I said, this is a sum of sums that's occurring. And this is where you have to be careful when you add sum as a column and you expose that, because it's the value is being resummed over and over and over again. So total build amount, if we look at the table itself, is $32 million for every row. So for all the rows that might have a bike rack in them, which is based on this product key somewhere over here, what's happening is that many rows are being summed together with the 32 million to give you $10 billion. Now, if you're working with odd numbers, it's possible you could get confusion here, and somebody could be, if the numbers aren't in fact big enough, there's enough data, they could make that mistake and see a problem here. Let's try this with our small table and see where we stand. So let's add another table here. In this case, I'm going to close this and do our small sample table. So we're going to add some sales there. Let's do the sale key because we'll see something there. Let's reverse those slightly so that they look better. And now let's add a new measure. If I add the sum X total, what do I get? I get the same thing. Well, let's add a new measure. So if I set a quick measure here, oh, this is nice. I don't really have a category there, so maybe that makes this hard. What would happen if I go to that table and I said new measure? And what was my measure calculation here? It was the sum X of those items. So we'll call this boy, that that's the column. New measure. This interface is a little wonky. If I click the wrong spot, it just kind of goes away. All right, so why is it doing that? Every time I click something, it's not very happy. New measure. I'm just going to do the formula first. So let's do that. So that way we have it. So we'll say sum X. Now we need a table. So this is where we're not going to filter. We're just going to take the table, and what we're going to do is return sale. And move that cursor so I can see sale amount plus sale rate plus sale tax as a measure. So that measure now exists, and let's change the name of this measure to be sales calculated measure, and we call it sale totals calculated measure. So maybe we're using the sale key as a product in this case, but we'll save that. get no errors. So let's come over here and let's see. I have the sales total as a CM measure because it has a calculator on. Let's drop this here. And what do I have? So 195 for my sales key of 5. That doesn't seem right. But maybe what I need to do is somewhere. Don't summarize. How about that? There we go. So if I don't summarize, now what I see is my measure looks like it's calculating the values correctly, right? So 13, if I go back to the raw data, 13 would be here, 2639, 2639. So I think in those places where you need to filter, you're working with a particular set of data where I'm going to not pull in the whole thing, and I want to avoid the sum of sum problem that I see here, and I see here, in fact. That's where the measure becomes more valuable. So that's an interesting place for me to stop and think, because I've wondered a little bit about columns versus measures, why one's important. This is a good example of something being important. And then certainly having it filter out in some place like this where I have related tables and only see that data. So let's save this and let's stop here. We're getting close to an hour for this particular class. Let me go back. Is there anything I want to summarize here? Let me get through this. So these are two staples. We know that, right? We would use sum, count, average constantly, min, max. Sum and sum x. So sum gives me the sum of a column. Sum x allows me to filter or to just use an expression for the table and then choose what to return. So that's kind of the differences. Now, if we go back to the stairway itself, this was level 6 we got through, class 4, if that makes sense. I was hoping to do average and count, but I'm thinking that likely what we need to do is stop here, and I'm going to say that average, count, and max will likely be easy enough to do now that we've been through a aggregate and iterator function once here. Let's try to go through average, count, and max for the next class. So 7, 8, and 9 will do that. Then we'll probably do product as 1, concatenate. I don't know. I don't know enough about these functions yet. So that'll be our homework. Well, hopefully you learned something. I think I learned something too as I stumbled along in these live stairways. Thank you very much for joining from Redgate and SQL Server Central. I'm Steve Jones, and enjoy the class.